Check this out. Isn't that a fantastic picture? I love this picture. It's a picture of our moon. I love the subtle colors in the picture. I love the detail. Check out all the craters. Do you see how they're scattered all over the place? And not only are the craters distributed all over the place, but there are different sized craters spread all over the place as well. There are some really big craters, like this one, and this one, and this one here. And there are some not so big craters like these that you see here. And all over the surface you see a whole bunch of these small craters, like these. Now, suppose that we wanted to explore the distribution of the sizes of the craters on the moon. One of the many tools we can use to do that is a histogram. A histogram is a chart that represents how data is distributed, like this. Down at the bottom we have our categories. We're going to keep track of really big craters, the not so big craters, and the small craters. And along the left side we're going to keep a count. So here's a big crater, so we'll put a check mark here. Here's another one, and then here's another one. And here's a not so big crater, and here's some more. And here are all these little tiny craters that we were talking about. Now, do you notice the kind of pattern that starts to develop with the check marks? How they make like a sloping shape? This shape tells us how the data is distributed. Now, there are all sorts of kinds of data, and they can have different types of distributions. For example, suppose we go downtown and start asking these people, what month were you born in? Here's our histogram to chart this. At the bottom there are our months, and we'll call them bins because we'll be putting people into those bins depending on what month they were born in. And along the side we'll place our count. So what month were you born in? November. Really, me too. February. August. October. When were you born? May. January, September, November, January, December, March, November, April, June, February. And one of the things that you'll start to notice is that this chart begins to take a particular shape. Now, do you see how the counts are spread fairly evenly among the bins? We can say that the month someone was born in is fairly evenly distributed. Another thing is that if we ask a random person what month he was born in, we can't predict with any certainty what he's going to say. He could say April just as easily as he could say September. Not all data is evenly distributed. Really interesting things happen with data that is not evenly distributed. Now suppose that when we go downtown, instead of asking what month they were born in, we ask, how tall are you? Here's our histogram, and along the bottom we've got bins from, say, 45 inches to 95 inches. So if somebody says that they're 72 inches, they'll wind up in the bin that shows up between 70 and 75. And across the side, we'll keep track of the count. Or you'll sometimes hear the word frequency, which means basically the same thing. So how tall are you? I'm 68 inches tall. How about you? 70 inches, 72 inches, 80 inches, 66 inches, 73, 69, 70, 71, 50, 70, 64, 70, 70, 64, 72, 71, 59, 63. And one of the things that you'll start to notice is that this chart begins to take a particular shape too. The high point of the chart, if you took the average of our heights, the high point is going to be right around there. The average is going to be right around the high point of the chart. Now, sometimes you'll see a line drawn through a histogram like this. Do you notice the curve? It's called a bell curve because it's shaped like a bell if you use your imagination. We say that data which falls into a pattern like this is normally distributed, and this chart represents a normal distribution. One of the cool things about normally distributed data is that it lets you make some predictions about the data. For example, we know that the next person we ask is more than likely to be between 65 and 75 inches tall. We can say with a high degree of certainty that he's not going to be, say, 88 inches tall. We can also say he's probably not going to be 49 inches either. He could possibly be, but he probably won't be. So that's what we mean by the normal distribution. We mean that data is spread out according to a particular pattern, a bell-shaped curve. You'll find that the average of the data is near the high point of the curve. You'll see that most of our data is going to be centered around the average, and will have fewer and fewer values the farther we get away from the average. So that's the normal distribution. I'm Brian Smith. Thanks for watching.